friends, so we are here for a video tutorial of Landsat imagery. So I have downloaded some Landsat imagery of Landsat 8. So I'll be here in this video lecture. I will be subsetting my area of interest, and then we will also take a look as to how to increase the resolution of your imagery using this pen sharpening tool. So here I will first of all load my I'll load my downloaded Landsat imagery. So is in raster format I have stored. So let me tell you one thing, that the image which I downloaded, it has different bands. So you will have to merge all those bands, or you will have to stack all those bands. So here I created this, already created this stacked Landsat imagery. So this option I used, layer stack, and then stack the different diff bands into a single image in IMG format. So this is the whole image. So now what I will be doing is, like, I will first of all subset my area of interest. So this is the subset tool. So the stack image would be as an input file, and the output file I will have to give the name of the place where uh, I will be the location where I will be storing my file. So here I will be giving it here. So I'll write subset 2015 image of that of September. Okay, and then after that you will have to load your AOI file of the area which you have to extract. So here my area of interest is a watershed called as aglar. So I already had a shape file of that of my watershed. So I changed it into AOI. I created an AOI file for that watershed in Erdas Imagine, and I'll be discussing how to create an AOI file from a shape file in the coming lectures. But this is how you snap, or how you subset your area. So all those things are done. Now you can select OK, and it's done. The work is done. Now we can load our subset image. So the image, we already know where we stored it. So we have this subset image already. So we'll load it. So you can see that we subset our area. So now we can remove the stacked image, because we need only this area. So this is our area of interest. So what would we would be doing next, that if you can observe, if I zoom on to this area, you can see that the resolution is uh, not good. We can't say that is a high resolution imagery, because the resolution of that of maximum resolution of that of Landsat 8 imagery is 30 meters, but we have one panchromatic band, and we can use that panchromatic band for pen sharpening. But we have to understand that whatever band you use for this, whatever image you use for this pen sharpening, is that the pen sharpened image should be geometrically registered, or it should be of that particular area. So both the image, the high resolution image as well as the low resolution image, they should be of the same area, they should be representing the same area. So now what we would be doing, I already had that TIFF file. So what I simply did is that out of that TIFF file, I did the same procedure what I did for this area. For my area, I loaded that TIFF file into this Erdas Imagine, and then I used the AOI file using the same this subset chip option. And instead of loading the file, for example, if instead of loading the input file as a .img, I loaded that TIFF file into this and then suggested the output, and the same method I followed, and as a result of which I got the image which was uh, high resolution image, and the subset which was a subset of my area. So I will show you on another window. Let's load that image. So the image would be automatically stored in img format. So this is the subset pan image which I have already got. I have already worked on it, and so this is the image. So let's try and check how these images are different in terms of their resolution. So if we zoom on to some particular area, so you can see that there is some difference existing, but the other image is in black and white. So let's go with resolution merge. Okay, so this is how we can do it. So there in this raster we have this pen sharpening. So there are different methods of pen sharpening, which will depend on your work. But here in this pen sharpening, so so we'll be using this wavelet resolution merge. So this is just for making you guys understand. So my dear friends, here we have this high resolution input file. So high resolution input file is that TIFF file which we converted that into img format, and then subsetted my area from that TIFF file. So I'll be loading that high resolution file. So that is this file. So this is the subset pan file, and then we have the multispectral input file. So multispectral input file is this file which we subset. Recently we did this, we just did its subsetting. So this is the multispectral file. So we'll load this file onto it, and we'll suggest where we actually want to store our data or the output. So here we will say that this image is pen sharpened. This is pen sharpened image. Okay, or we can also 2015. Fine. Okay. So different methods, principal component or IHS or single method, okay, by linear interpolation, and you can also select that we want to ignore that 0 in our status. So we are done. Our image has been already created, so we can open a new viewer and to load our image that we recently got. So this is the pen sharpened image which we got. Okay, so we can link both the views, so that we'll have a better understanding as to what we actually got. So for example, if we zoom on to a particular area, we'll get to know that the image which we got is of good resolution. So for example, C. So this is the main difference between those two images. So the second image is of a good resolution, and you can see the difference between two different images. We can zoom on to this urban area. You can see that there is actually a major difference, because we use that 10-meter resolution and we merged that particular area, and we can see a major difference in those areas. Pixel, color, and all that is different. Okay, so thank you very much for watching this lecture, and if any queries, uh, please comment on this video if you have any queries regarding this video. Thank you very much for watching the lecture. Thank you. This is Amir Shah signing off.